We've been looking at volume this chapter, and today we're going to look at another way you can find volume called the shell method. The shell method is a way to find the volume of a solid by taking the area between a graph and the x-axis, and we're going to rotate it around the y-axis instead of the x-axis like we've done previously with the disk method and the washer method. So we're going to take an equation that's in terms of x, and before we've always, anytime it's been in terms of x, we've gone around the x-axis. Now we're going to change that and go around the y-axis. By doing that, it does change what we're going to be using, or our integral that we're going to be using to solve. It's no longer going to be pi times r squared. What that's going to look like when we do it this way with the shell method is the volume is going to equal, and we're going to be doing our interval on A to B, where the interval is on the x-axis. So we're still going to be doing everything. Equations are going to be with x, interval is going to be with x. The difference is, though, we're going to be spinning around the y-axis while everything's in terms of x. When we do that, what we are going to do is multiply 2 pi times x times our function dx. Okay, why are we doing this? How does this work? Well, when we have some function, let's say this curve right here is our function f of x. Okay, that f of x is kind of going to be like our height. So this is the height that we're going to have when we spin this around the x-axis. So we're going to be taking this, rotating it around the x-axis, or the y-axis, I'm sorry. And what you're going to get is kind of you're going to get kind of the same thing. And we're going to be spinning this around the y-axis. So it's going to create kind of like a cylinder shape with this little hole in the center here that's kind of hollowed out. So we kind of get a hollowed out cylinder, which we call a shell. And that's the reason this is called the shell method. You get kind of like a hollowed out cylinder thing. But this f of x throughout the whole shape, throughout this whole cylinder shape, is our height. So that becomes our height. X, this 2 pi x kind of becomes with this cylinder type shape, becomes our kind of like our circumference. And when you take the circumference times the height and then integrate it from A to B, that's kind of like the width of the shape, you then get the volume that we're looking for. So that's kind of how this works. And just kind of seeing what that would look like a little better than my drawing, you'd get kind of this shell type shape where it's there's a hollowed out piece in the middle. So that would give you a volume by spinning it around the y-axis that looks like this. It gives you different volumes than you would get by just going around the x-axis. All right, let's try a problem out. So on this one, we're going to let R be the region between the graph of this function and the x-axis. We're going to use the shell method to find the volume of the solid form by rotating R about the y-axis. So this is a shell method problem because our equation's in terms of x and we're spinning it around the y-axis. The first thing we need to figure out is what is our limits going to be. Now, if we are looking at the shape right here of this function and the x-axis, we know another equation for the x-axis is f of x equals 0 or y equals 0. What we could do, one way we could find this out is to put these two equal to each other. So we could put negative 2x squared plus 12x minus 16 equal to 0 and figure out where they intersect. Where does that function intersect the x-axis? Well, to solve this one, we could use quadratic formula. It's a quadratic equation. But if you notice, all these terms can be divided by 2. Or in this case, let's divide by -2 so we get rid of the negative in front of the x squared as well. So let's divide everything by -2. See what we get. That would cancel out our -2 there, and we just have x squared. 12 divided by -2 is -6. -16 divided by -2 is +8. 0 divided by anything is 0. Looks like now we could do this one with factoring. What's going to multiply to +8, add to -6? That would be -2 and -4. Putting them both equal to 0 now, we could get our limits. So it looks like our limit is going to be from 2 to 4. So when we're doing this one, our volume equation is going to be from 2 to 4. Another way you could get that would be looking at the graph. So we could also graph this, look at the graph from your calculator to help us do it too. What you would want to do is go to your y equals, enter in the equation that we just were looking at, -2x squared plus 12x. What was our equation? -16. And we could graph that one out. And you can see the graph on here does come up. And you can see it intersects at 2 and at 4, just like we had said. So right there and right there is where it intersects. So you can get the same thing looking at the graph. All right, let's go back to our problem here. So we know where it's going to intersect. We know our limits across the x-axis. Now we want to put in the rest of the formula. 2 pi x is always going to be part of the shell method. You're always going to write that in there, 2 pi x times our function, and our function in this one is the -2x squared plus 12x minus 16. All right, now we're going to look to simplify and solve that one. Just like before with the disk and washer method where we had pi, here we have this 2 pi, and that is a constant, so we can look to bring that out there. Now this x is part, we can't bring that out, that's not a constant, so that needs to be included with the rest of our function here. What we can do with that though is distribute it through to make our function a little bit easier. So what we have now is 2 pi. We're integrating from 2 to 4. If we distribute that x now, we got 2x cubed plus 12x squared minus 16x. All right. Now we want to simplify the integral or find what that's going to equal. We could do antiderivative. You could use your calculator to help you calculate this out. Let's do antiderivative, see what we get. So we got 2 pi. Antiderivative, remember, you go up a power for power rule, so this would be x to the 4th power. Reciprocal would be 1/4. If we multiply 1/4 times -2, that would be -1/2. Okay, let's go on to the next one. If we go up a power here, this would be x cubed. Reciprocal would be 1/3 times 12 would be 4x cubed. And same thing with our last one. Reciprocal would be 1/2 times 16 would be 8. All right, so if we solve that out now, we should be able to figure out what the volume is going to be. So we'd want to plug in 4. We'd want to plug in 2 and evaluate it from there. And plugging those numbers in, we should be able to get it to come out. Let's see what we get. So if we do -1/2 times, let's plug in 4 first. We got 4 to the 4th power plus 4 times 4 to the 3rd power minus 8 times 4 squared. That comes out to look like it equals 0. minus, now we got to see what do we get when we plug in 2. So we want to do the same thing, plug in 2. If you plug in 2, get negative 1/2 times 2 to the 4th plus 4 times 2 to the 3rd minus 8 times 2 squared. And that comes out to be negative 8. We got 0 minus negative 8, that would be positive 8. And multiplying together, the answer, or the volume, is going to be 16 times pi. So the volume here would be 16 times pi. What volume did we find? Remember before we graphed this one out, that was what the graph looks like. And we're spinning it with shell method around the y-axis. So if we spun this around the y-axis, what it would kind of look like is we'd have this shape, kind of this arch shape, and we're spinning it around. So there would be there'd be kind of this hole in the middle here. It would kind of be like this arch shape all the way spun around. It would kind of look like when you're all done. If you've ever seen like a bundt cake, it would kind of look like that. You got this tube that's kind of like this parabola spun all the way around with the hole in the middle. So that's what we would be finding the volume of here. That's the 16 pi that we found out. All right. So shell method, that's kind of what shell method's about. We'll look at this some more tomorrow.